Welcome to the part 2 of how to live stream series. In part 1, I discussed about how to set up the audio-visual equipment. For example, this top camera you see here, this is top camera, and also near me, there are like side camera. In front of me, there are another front camera. There are also projector. Here, there are like laptop. So we discussed about all this. Also, we discussed about OBS, how to use OBS, how to link with the Zoom. That's in part 1. In part 2, I will talk about content preparation. As I mentioned in the description below, this live stream series is targeted to those who want to do like experimental style or demo style live stream. It also can be used for showcasing your product or coaching, online teaching, and so on. It's different when you are live streaming for gaming. For example, for gamers, if you want to live stream your game, you just need to have one webcam or camera and then your PC, you play a game and you just react on that. If you are live stream, if you're doing the vlogging, live vlogging, then you just take your camera, have the internet ready, and then you just talk during the vlogging. So that's different than this series is targeted to. This series is about demo. It's about doing something, that presenting something to the audience. You need things, you need physical things that make the difference, because physical things require space. For example, let's say the chess set in front of me. I can show like this, but then you cannot really see. The show is more about me rather than the chess set itself. And I also can show like this. You can see I have the top view and also I have the side view. The problem now, the top view here, you can see here, I'm moving here. The top view here is not really nice because even though you can see everything, but you cannot really differentiate this and this. This piece and this piece is two different things, but from the top it seems the same. On the side view also, this one, that let me, move it so that you can understand what I'm talking. The field of view is quite narrow, so it's limited. So it's all depend on what you want to show during the live stream. When you are doing demo, you have a product. You need to make sure the camera takes can sort of like encapsulate everything that you want to show. For example, this chess set, you can also do live stream like this. You can show the computerized image of the chess set. But some people don't like this thing. Some people, they are more prefer to see something like this, like real stuff. You can move like this, you can move and I can show like this. Some people like that. So it depends on what you want to show to your audience, what interaction you want to have with your audience. And even if you use this physical chess set like this for your coaching, I think it's doable. Because you only need a very small space to do your live stream. But if you do demo, it's a different matter, because demo normally require you bring things from here, item from there, and also on top of that, you want to show the demo itself. Whether it's working or not, you need to practice ahead before the demo itself. So this video is about that, content preparation. Okay, we are not talking about the chess, so I think I can wrap it down and put it aside. By the way, that's black to move. For those who are interested, find a way to make. Okay, we're done with the clearing the table, but before I can fill up this table with stuff, I have to practice doing the experiment myself. Even though I already know, I already have a rough idea what I'm going to do and what I'm going to say based on my previous experience in face-to-face lab, doing live stream is totally different animal. I have to come to the lab and practice. There are a number of reasons for that. Reason number 1 is to gather stuff. For example, I don't want during the live stream, I want the water, but the water is in the next room. So I need to move there and waste time. So I need to make sure the water is near me. So that's reason number 1. Reason number 2 is to estimate. For example, only by, for example like this. I show you lah. So for example, let's say I have this 2 beaker and I have this red liquid. I want to pour this red liquid into this 2 beaker in such a way that it will below the level of this line on the paper. I will show you the paper first. So can you see this? Let me focus first. Okay, let that focus. So you can see the line. That line is 1 centimeter from the edge. Okay, I want to pour this liquid in such a way that the level will not be beyond that line. Okay, so let's say To demonstrate, let's say I put 5 ml here and 10 ml here, double the amount of here. So let's say I take the pipette here and then I just pipette 5 ml. I already set to 5 ml. I pipette 5 ml here and then double here. 5 ml here and then 5 ml here. Okay, so I already double that thing. Okay, let's say now I put it on the side. So let's say this thing now, let's say I put on this 10 double volume of the liquid. So if I put there, I don't know whether you can see or not from this thing, but the idea is that if I put on this 10 ml volume liquid, the level of the liquid will be above the line. But if I put on this 5 ml liquid, wait, okay, I hope you can see from that, the level will be below the line. This is important because imagine that you have a chemical on that line and you don't want that chemical be dissolved by the liquid. So you need the liquid will be below the line. And if let's say you don't observe this thing, you just pour the ambiguous or arbitrary value of volume, into this chamber, then you will ruin the entire experiment. So that's reason number 2, to estimate. Reason number 3 is to feel itself, to feel the technique itself. For example, I give the example, it's easy lah. So for example, this is Bunsen burner. Where is the mic? Okay. So this is a glass tube. Okay, let's say I want to make a spotter. What is spotter? Spotter is like a straw. It's like a straw, you know straw, right? It's a straw, but it's smaller than straw. The diameter is smaller than straw. So for example, here is glass. I don't know whether you can see, but I hope you can see it what we call it, focus there. So this is a capillary tube. Okay, it's hollow in the middle. Okay, but then both end is closed. So it's like a straw, but with a closed end. So now I want to make a spotter. What is spotter? Spotter is something that is smaller. The diameter has smaller diameter than even this. So in order to do that, what you can do is that you can open this. You can open this flame. Wait. Okay, there are blue flame actually. There are blue flame there. Okay, so I put here. And no, you cannot see. Okay, maybe you cannot see. But anyway, so this, the idea to make spotter is to hit in the middle and then to pull it. So if I put in the middle, what I mean by feeling is that if you don't do this, then during the class, you are like, what happening now? You are just getting this, unusable spotter. You need to get the feeling how strong you need to pull and when to pull and so on. So you need to do like until you get the feeling. So you put in the middle and then before it's melt, you bring up and then you pull and then pull. Even this also, if you see here, it's not good spotter lah. For example, there are fire there, so it's not really good spotter there. So you need to practice and practice until you get it. So let me try again the last. So I hit it in the middle, and then I pull. I hit, pull, hit, pull, hit, pull, hit, pull, hit, pull, hit, pull, hit, pull. Oh, okay. So that's why you need to practice. Okay. So even this, you see, still not. Let me show you. Still not nice lah. Still not nice. So again, last. So that's why you need to come early. Not early. I mean, try ahead before your live stream. So let me do again. Pull. Okay. So now looking good. Okay. So now let me close this because it's quite hot here. So let me close, put there. So if you see there, okay, if you see here, let it focus first. Okay, if you can see there, it is like they are like narrow middle tube there, where you can sort of like break in the middle just like that, and then you get a spotter. But to make this as a spotter, you need both end to open, meaning that here you know the middle of this capillary tube is hollow, but as I said before, this one, the end is closed. So in order for it to work as a spotter, both ends must open. So here in the middle you can always like do like that, but in the end here you cannot. It's very difficult to break this thing at the end here. Okay, you cannot break in the middle here because the idea of the spotter is that you want to dip it into something. Let's say you have this glassware and then you want to dip, there are some water. Let's say I put this what we call this thing. Let's say you have this compound. Let's say you have this compound here inside this thing, okay, inside the flask, and then you have a spotter and then you want to dip this spotter into the what we call into this liquid. If you break in the middle, then the spotter become too short and then you cannot even reach there and make very difficult lah. So you want to maintain the spotter length, but also at the same time you want to break in at the end here, because that's basically how spotter work. You need both end open. So another reason number 4 is to prepare the extra tool that is not mentioned in your what we call in your lab manual. For example, lab manual tell you, okay, prepare this, prepare that. But in lab manual, sometimes they don't tell you in detail what you need to do. For example, let's say I want to break this, I need to have something that can clip this thing. So I need to find something like this, the plier like this. Okay, so for that I can just cut like this, pump like that. But the problem now, if I cut like this, being very big, what we call this diameter is at the end, the glass will shatter. Okay, the glass will shatter. So that's why practicing ahead tell you that you need something like plastic like this, so that when you do live stream, you can do this clipping inside the plastic to avoid the shattering of the glass. So that is reason number 4, to prepare something that is not mentioned in lab manual. Now come reason number 5, which is to save time. If let's say I need to just make one spotter during the live stream, then it's okay, I can do that during the live stream. But then say I need to do like, for example, 20 spotter during the live stream, because I have 20 chemical, then I cannot do it one by one during the live stream. It will waste a lot of time. So better idea is just to prepare in advance the spotter here. So you can prepare the advance this thing. So let me show you. So prepare in advance all the spotter that you need. Already you already break the what we call the both end. So it will save you a lot of time during the live stream. So that is a reason number 5. Same goes to the chemical like this. Okay. Unless the experiment is about how to use the balance, you can just weigh the amount of the compound that you need, the substance that you need in advance, and put it in, for example, like inside this aluminum foil, or you put it inside this flask in advance and seal the what we call the top. So that saves you a lot of time. During a physical lab, there are technicians there, there are students there. You can always say, student, okay, do this, do that. But during live stream, everything is on you. It's all depend on you. So you need to prepare in advance to save time. Reason number 6 is to save space. For example, this chemical is already take some space. If let's say I have another chemical here, this liquid, another space already occupied. So you need to save space, because you don't want clutter your demo table with all this what we call this stuff, this chemical. So the way you can save space is that to put this into what we call the small beaker, or you can put this what we call this liquid into small bottle like this. So it's what we call, it can save a lot of space lah. Imagine now it's only 2, but imagine you need to use like 10 of this liquid and 10 of this solid. If you just use this bottle, the one that come with the bottle and also with this container, then of course everything, your place will be totally mess. So better put in this small bottle or beaker for your usage during the live stream. Anyway, if this chemical is dangerous, is fuming, then Like it or not, you cannot do on this table because you need to do it in the fume hood. But because for my live stream, I only use a dilute acid, dilute alkali, I think it's okay to put it on here and then do during the live stream on this table. So you know your chemical well lah. If you are working with microbe, for example, some people working with microbe to show how it grows and so on, microbe is sensitive to the contamination. So you cannot do on this table like this. So like it or not, you need to do in a laminar flow. You need to set up all this thing, all this what we call this thing, this side, whatever camera, in near the what we call near the laminar flow lah. And also talking about microbe, normally it's not like chemical experiment like this. You normally incubate them. You will wait them to grow. If you aim just to see the end of the growth, you can just grow it in advance and show the result during the live stream. But if let's say the experiment need you to check the growth in the interval time, for example, every 30 minutes you need to check the growth, then you can record in advance and play the recording. But it's no more like live stream anymore. It's recording because you record. However, if you don't do that, then what to do while waiting for 30 minutes to pass? So in physical lab, it's okay because student can wait. Student can wait, but when you do online, you need to consider every second because every second costs internet data. And finally, reason number 7. Reason number 7 is to adjust. For example, inside this manual, they say that use 10 gram to perform this experiment. But then you found that you open this chemical and then you found, oh, I don't have 10 gram. I only have like 5 gram like that. So you need to adjust. You need to use that 5 gram and try that 5 gram for your experiment. And because you already changed the grammage, the weight, the amount that you use during the for the experiment, the rest also need to be changed. Because you cannot just change this and then let the other become the same. So that's why you need to learn how to adjust. If there are not much left, then you adjust. You use a little. If they are extra, then good for you. Another example say that inside this manual, they ask you to do certain ratio. For example, 9 to 1, 8 to 1, different liquid A to liquid B, 8 to 1 ratio. But then when you try that during the experiment, you cannot find, you cannot get the result that you want. So in that case, you need to also adjust. For example, I can show you, where is the thing? Let me show you. Okay, so I hope you can see here. Oh, here. I think is, I don't know whether it's like the other way around the mirror. I don't know how to mirror this camera yet. But you can see now, even though inside this manual it says using this, using that, but you see I'm scribble a lot in this, what we call in this manual, showing that I'm trying different method. Because when I try the method that mentioned in this manual, I cannot get the result that I desired. So yeah, you adjust. That's why you adjust. But you need to understand why you adjust, why this thing happened, why that thing happened. Because you need to explain. You don't just adjust for the sake of the result. You need to know why you adjust the thing. So you need to dig deeper, find something in the internet and so on. So that's basically the reason why, the 7 reasons why you need to practice.